Okay, testing audio. 1, 2, 3. Okay, sounds all right. Today is compiler day. Sorry, we got off to a little bit of a late start, but we can work a little late, so that's fine. Today, compilers. Oh, I did not update the stream title. Wait just a moment. I did everything except click the button. There we go. My bad. Typed it, didn't remember to push the button. So, strap in, get yourselves ready. Get your favorite beverage of choice, and we will get started. We got to where we can take a string text and generate a non-deterministic finite automata. And we've drawn it two different ways. We've got like a tree structure, and then we also have a table structure. Honestly, that's not bad, but as a warm-up task, we may play around with some Graphviz, which I have not actually used before, so I was just reading up on some documentation before we started. So hopefully I know enough now to be able to do a little bit of Graphviz today. We'll admit, let's see, number 3, who is my roommate? I live in a house with my wife and 9 children and my father-in-law. So if you want to call them roommates, I've got numerous. And welcome to the chat. Co-host in the background. Oh yeah. Well, you know, this is my last coworker. They just wouldn't listen. It is a busy house, so if my kids get loud in the background, I'll sometimes mute my mic for a second while I yell at them. But in general, you can probably hear a lot more of my personal life than you ever wanted. I haven't really thought of a name for my skeleton yet. I mean, there's the obvious one, skeleton. We could always go with like a Yorick, but I just haven't settled on something that sticks. I could call it Duck. I thought maybe Jarvis. I don't know. I haven't really settled on a name for it. So let's pop up a new stream for today. I am off by a week somewhere. That's awkward. We added anchoring last time. Am I misremembering something? We don't even have to reduce. Oh no. Oh yeah, last time. I forgot we didn't finish anchoring. So maybe we need to finish anchoring. Which language is this compiler going to be for? Okay, the plan. This compiler is going to be for my own personal toy language. And on the way, we're going to build a tokenizer generator using a Thompson NFA construction method and explore some things that I don't think are explored enough with PDFAs. We will build a built-in parser generator, an LALR parser generator eventually. You don't have to use it, but for those that like to work with the BNF style grammars, just have it there available. I don't have anything new or innovative to add there. It's pretty bog standard LALR parser generator. Then we will move on, but it's going to be a while. We're still in tokenizer generator land. And I'll throw out the same caveat I always throw out. Writing a tokenizer is not hard. A tokenizer generator in most cases is probably not necessary at all. I do it because I think it's an interesting, fun problem. So don't think that to build your own compiler you have to also write your own tokenizer generator. Actually strongly not recommended. But I think it's fun. And I work on what I think is fun. The language my toy language has not been well fleshed out. I've prototyped a bit of stuff in Python. It's a C-like language, but mostly to play around with different language constructs that I have never seen anybody else build in. We'll see. My toy language, I did have it actually compiled down to bytecode for a virtual machine I wrote myself. But, it's not useful. It's just for me to play with ideas. This is more for education than anything. So I completely forgot we did not finish anchoring last week. Start of line, end of line, or text. Well, I don't think it's hard, so let's just add it in real quick. Character, an inclusion set, an exclusion set, any character. Alternate 0, 1, 0 more, 1 or more, and a group. Anchor. Start of line. Yeah, sure. We can do it that way. Five, 6, 7, 8, 10. That's not quite all we have to do here. Operation names. So things will print normally. Sounds fun. Yep. We try to have fun, try to learn. Like, I don't come into streams very well prepped most of the time. I'm not I don't think of myself as a content creator. I'm not here to create polished educational videos yet. I'm just here to program. If you want to watch, go ahead. If you have questions, throw them out. Otherwise, I just kind of code and talk stream of consciousness while I go. I'm happy to talk about off-topic things as well. Yesterday we had a discussion about AI while we were doing the game development stream. Or language choices, C versus Lisp versus whatever. We're happy to badmouth almost all programming languages. So yeah, we're just here to code and have fun. So we're adding to our regular expressions anchoring. Really, it's not that bad. I think all we have to do is catch it somewhere like here, maybe. We're going to say start of line. The dollar sign is the end of line. That's basically it. In escape. So if we're escaping a character, we check for all the characters that we don't care if they're escaped, so although this is inside of an inclusion, so the other in escape happens here, not in the inclusion. Ah, yes, here we are. Already added this. What am I doing? Ah, this one right here. Oh, I already put them in. As characters we don't have to escape, or we should escape. So if it's not in this list, then there's no need to escape. Okay, so we've already added it. We added our anchoring there. That's almost it. Reduce anchoring. So let's talk about what we're doing here. When we walk through our string, we're building up little teeny fragments that we understand, like character sets. So we have like square brackets that contain like A through Z and 0 through 9 and dot and comma, right? It means match any of these characters. So that's all one chunk that we parse out. If we get a plus, that means one or more. So we parse that out as a separate object. And what we have, if we make a non-greedy modifier, that's another thing we do. But checking for, like, is this the end of the line? Meaning look ahead. Are we at the end of the string, or is the next character a new line character? Then we can do that. And this does not consume a character. It doesn't move us forward while we're checking our string, which is an important thing. The other thing you have access to will be this, right? Start string. So we've gone through, we've built up the list of all the things. And now we need to, so we put all these fragments next to each other in a list. Now we're going through the list and we're saying, we've already processed this once, processed this has been processed. So we say, walk through the list and look for asterisk, plus, or question mark. And look at that fragment and grab the previous item and put it underneath in a specific way so that these operations happen. 0 or 1, 1 or more, 0 or more. Then we take elements that are next to each other and we mush them together using concatenation. So if we do like A, B, C, it means we expect the letter A, followed by the letter B, followed by the letter C, followed by, maybe a digit or white space, right? These are all next to each other, so they just get concatenated. There's no syntax for it. Then we check anchoring. To my mind, cardinality cannot follow anchoring, so we can't do like this. I think there's actually a rule. Is there a rule? These have to happen at the beginning and end of the pattern. When used as an anchor. Oh, why does anchoring happen after concatenation? That's always a question I've had. When used as the first character of an entire basic regular expression, so only if it's the first string, first character, shall be an anchor when used as the last character of an entire regular expression. All right, so I have to be a little bit pickier about how we parse this. And actually, anchoring doesn't require any reduction. You know what? I'm just gonna leave it the way I'm doing it. It's okay. We don't have to follow all the rules of Perl. Yeah, we'll just keep doing it the way we are. Anchoring doesn't need any special action on our part. Literally. We can just do this and ignore all our inputs. What I mean by reduce is we're taking like neighbors and putting them underneath. So we have like an alternation operator, like A or B, meaning we match either the character A or the character B. When we get to reducing alternations, we look at this and we say, well, let's get the thing on the left, the thing on the right, and put them underneath this alternation. Here, there's nothing to reduce. It literally just means check where we are in the string and what comes before it or after it. There's no reduction necessary. Okay, that's good. I guess we should test it. So go to main. Right now we're just doing a pattern in the first argument. We go to our shell. File. Oh, in the log. We should definitely add update our logging so that we see when we've got it right. State ID, rule ID. Okay, all this makes sense, so we might just collapse this. Yeah. We don't have to do anything special with these. There we go. We'll run it again. Builds. Debug. I need a regular expression, so like ABC or D end of string. Okay. That's very clever of Bash. There we go. So here's our pattern. Here's the NFA displayed as a tree. And here it is as a table. Here's the start. None of these nodes can accept because I don't think I'm told. I've told the program what to do about that. So NFA state can accept. Can hard accept, can soft accept. There, I think that's it. That's all we had to do. Now it should detect that the $sign can accept. Start of line. Where did my ABC go? Okay, we clearly have an issue. Something about start of line is causing. Oh, I thought concatenation would get all that. Fragment, next fragment. It's an alternate. We don't do anything. That's dealt with later. Otherwise, take our current fragment and point it to the next fragment. Make a new fragment and append all the remaining outputs. So we need to match. And rearrange things. So if current fragment start state op equals NFA state operation start of line start of line. End of line to something. Just see if the flow is going where I expect. Yes, anchoring. I forgot we hadn't done that last week. It's a problem when you only work on a project once a week. Forget what you were doing. Anchoring is doing strange things to me here. Cardinality. Destination. This is called twice. Because it should take the. All right. Next frag, start state. Operator name. Thread, start state. Opting. Okay, so I expect start of line to want to append the letter match A. So it'll be just a match. Then it'll want to append to the start of line, because the start of line is still the thing we have hold of, and the A is now underneath it. And the next time through, we have start of line A, and then there's an end of line. So we're going to append end of line to that list. So it will still say start of line here. Um, I forgot it's a static call. All right. So we append a character to start of line. Then we append an end of line to start of line. And then, just like I said, this one print basically the same information. So what have I done wrong? This should be a very simple thing, like this. It should look like this. It should be a start of line, end of line, A. Start of line, character, end of line. A with a B underneath it. Or start of line, B, A, end of line. So that's odd. Shurizzle, hey, welcome to the stream. How's it going? We're building a regular expression parser to take a pattern, turn it into an NFA, and then we will turn an NFA into a DFA, and then we will use that to generate Tokenizer code for us. That's the plan. And I'll point out, as always, you can build your own Tokenizer fairly trivially. They're not rocket science. It's easy to walk forward over characters and do a bunch of if statements. It's not hard. We do this because I like to. So, tokenizer generators, probably not necessary for anybody else's project. I just think it's a fun mental puzzle. Maybe I'm weird. Though why? It's as far as start of line. There are things under start of line. Let's look for this one. Move this up closer to, or down, move it down. Here. Ah. Okay, I know what's going on here. We weren't telling it how to patch things onto this state. Okay, so when we create a fragment, we say, here's the state we're in, and here's the output that we need to map when we patch things on. So it's saying, here's the dangling bits that we have to attach to other things as we reduce our statements down. There we go. So now we create a new state, and we make sure we provide it with the dangly bits that have to be mapped. In this case, this basically means the out one means we just go left, and it's the next character in our string. If I have an out one and an out two, then that means there's a choice, right? Okay, good. That's probably what our problem was. So, all right, we don't have a constructor for that. We can make it work anyways. State point to opt equals that. Okay. And now magically all of a sudden, start of line followed by a character followed by an end of line, and the end of line can accept. Oh, interesting. Match A, match 0. It's a match 0. That seems odd. One or more end of lines. That's what happened to my question mark. You look at the previous thing, if it's one of these special things, you just flip a flag to say this is non-greedy. Otherwise, it's just a 0 or 1 test. Not sure why that would result in a 0. $, 0 or more, it's also not working properly. What if we put something in here that's not a $sign? The $sign is interacting strangely. So plus, what plus does, this means we have to hit, let's put the $sign back in, end of line, means that we first try and hit the end of line, and we can keep looking for more end of lines, which actually doesn't make any sense. Okay, well, why don't we do this then? There are several things for which these don't make sense to look for. So maybe we ask that question now. Previous op equals NFA state operation something. Now, which ones don't make sense? NFA state. It does not make sense to put a 0 or 1 after a 0 or 1, or after a 0 or more, or after a 1 or more, or after an alternate, or these. Basically, it should work for character, inclusion, exclusion, any, and group. All right, so let's do that. Character less than or equal to prev op, and prev op less than or equal to any, or previous operation equals group. And then lastly, put parentheses around everything and say not. Okay, log error. NFA state, op name of prev. Okay. Otherwise, we do the normal thing. I think that makes sense. Same thing for a plus. Alright, that should at least give me warnings about me being silly about moving my NFAs. have op. What's not declared? Oh. Guess we do need to get that in the right place and probably here as well. There we go. That should fix that. Unused variable. Oh, I see. Okay. We will slowly make this a better and better tool. Cannot add question mark after. Whoa. What is that mess? Oh. Why do I have it? Needs to be an S. There we go. Streamer brain. Cannot add a question mark after end of line. So it actually just didn't do anything, which yields a working NFA in theory. Okay, so now we go ABC $. Put the or back in, and now we alternate between start of line, character, character, character. So alternate between the start of line followed by AB, or we get C at the end of the line. So that's what I would expect. Done. Journal. Did add anchoring. Oh, this was just the example. Anchoring added. No reduction necessary. Also added better checking for cardinality. Do not follow something silly. Okay. Get status, get add everything, get init, anchoring added. There, we can now do anchoring with our NFA. Phew, okay. Now, we have these two views of our NFA. It might be more helpful if we outputted we're able to output a what's it called? A Graphviz. I want to do it. I haven't used Graphviz before. I've seen it before, but this is like the perfect thing to use Graphviz for. So let's go into I can remember my path structure here. Okay, we've got log table, log tree. We're going to do void export Graphviz. Const char star file name. Okay. Log table. Here it is. Export Graphviz. Not supported. Press warnings around not using the file name. We'll get back to that. Main. export Graphviz. Test dot. Okay. And we can keep this fairly simple, actually. Let me think. So one thing we want to pay attention to is the rule number. Nah, let's not overthink it. Let's not overthink it. Kind of want to overthink it though, just a little bit. I'm going to resist. I will resist. Let's compile, make sure that at least outputs something. Oh, we need to take those log statements out. Also, let's do that to our journal. Store staged source main. And the NFA, we don't want to stage that just yet. Patter-to-NFA converter. Those should be errors. I don't know why that's that. There we go. These log statements can go away. It add source pattern. Oops. There we go. Git dash a check our status. Git commit dash element dash no edit. There we go. Okay, we should have committed it that way. Yeah. Let's run this. That's not what I wanted. Export Graphviz not supported. Perfect. Now it will be. We need standard IO. File star out equals F open file name. Did not work as intended. We're gonna write as text if count is null. Could not open file name. Otherwise, onward we go. fwrite output file digraph. Let me look at my notes. I did a little bit of research before we started this. And this is an initial pass, so it's okay if it's a little bit ugly. Okay, label. Let's just get an empty in here. Label equals NFA has a thing called the pattern. We do get the pattern somewhere. There we go. Which probably just now let's just do a pattern. Nope. Does it allocate new memory for that? Do I have to clean it up, or do I? I do have to clean it up. Okay, that's fine. Char temp equals. We'll use the pattern, and we'll delete our temp. Want to put a blank line, then for int index equals 0, index less than states.size. Plus index. State equals underscore states at our index. We're going to write out something like this. State modulus 03D which needs the index. We can put up index plus 1 if we want to. That's not consistent with what we're outputting on the console. We're starting at state 0. So depending on how consistent I want to be, maybe we don't do that. Then some brackets and some stuff. Let's deal with shape first. Shape equals something. Style equals something else. And color will equal something. That's all we really need here. So the shape, if the state can accept, break this up. If it can accept, we want our shape to be double circle. Otherwise, we just want it to be circle. State to is what did we call that? NFA state. Is start. There we are. And that is public information. You know what? We can make this a constant so we don't accidentally do something stupid. If it's a start, then it's filled. Otherwise, now I need to go look at empty style. I don't remember what that's called. So Graphviz. Let's let me just put the link in the chat. Revest, how is it going? So far, so good. We added anchoring to our NFAs, and now we're generating a Graphviz view of the NFA. So that's where we're at today so far. It shouldn't take long. It's not going to be a beautiful graph. It'll be fairly simple. So there's a link to Graphviz for those who are interested. Style. Valid on, yes, what's the list of? I guess we just go double quote. Okay, and then if state is start, we can choose a color, which I don't know what the format for colors supported is. Let's look at fill color. If the value isn't a color list, a gradient fill is used. Oh. Could make it cool, but color list. Okay, so I can do a decent, okay, that'll work. Here we go. So we can choose our own color. We want color list. So we're actually gonna go style is radial. Ink. Do we have to do this? Do we have to do style filled? I wish there was like an example attached to the documentation. Style radial fill color equals, okay. Fill color equals oh, so this was where I wanted to double quotes. Okay. Okay, if it's a start state, then what we want is let's go from like rate, so 128 would be, oh goodness. 80, there we go. 80. Well, let's go 0, 0. No, no, no. 0, 40. 20, 40, 80. Semicolon. 0x f and 3. Otherwise, fill color really doesn't matter. So we can just do like 80, 80, 80. So that'll output a whole bunch of states and no connection information, which is fine. So let's just see what that looks like. File. It should just be a list of unconnected states. NF. Fine. I don't know why I did it that right. That's fine. Just a moment. Ah, yes. Wi-Fi passwords. Okay, intense. Invalid conversion. Okay with that. Okay, we can do that too. I've standard int. Okay. Okay. Other than some minor typos, should write something out. Actually, file written. Just so we know for sure what's going on. Okay. Boom. File null was written. That's not great. That's because I didn't finish that one. Okay. Now, if we open test dot, we forgot to put the new line character, so that's always perfect. But already my evil nefarious plans are coming together. List of states. Hey, that looks better. Okay, we have a list of states and we have a label. So if I go download Graphviz, which I have not yet done. Oh, another thing, Graphviz has this great little tool where you can play around with it in real time without having to actually download anything. So low effort Z's, a compiled hello world, a source file, object file, the executable, and also 23 more files that are just auto config stuff. But I managed to trivially package it with the GUIX, which is very nice. Kind of cheated. 5 files are license, readme, and change log. Hey, pad your numbers. Pad your numbers. Let's see here. Is it time to plug the old? Let's go plug the old Discord here. So if you like what you're seeing, go ahead and hop into the Discord to get notifications when I go online. There's also Twitter in my About. You can also go to my About and find YouTube and Rumble where I upload all my old streams so that they're not lost when Twitch discards them. This is our 8th week. We've almost finished 8 full weeks of development and streaming. So, not very long, but it's come along nicely. Well, good work, low effort Z's. That's often the hardest step, is getting the first dadgum compile to work. Okay, so I'm going to go grab a Windows installer. Zip archive. Sure, oh, not 32-bit. Ah, no, cancel, cancel. 64-bit, thank you. I'm on a modern computer. Let's drop that on my, oh, let's put it, let's do the installer so I can use it on my other logins without having to faff about too much. I kind of don't like this modern installer stuff. I liked it better way back in the day when you could just move files from place 1 to place 2. An executable file, you just click, drag, go. All right, so I'm just installing it. Graphviz, not a big deal. Add Graphviz to the system path for all users. Yes, please. That was the whole point. I ran the installer, so I wouldn't have to do that manually. And install it. So, in theory, where's my, I had a tab open for command structure for running it myself. Whatever, we'll go here. Command line. Dot dash T. So first of all, Graphviz should exit what? Oh, dot. Dot is not recognized. It says Graphviz added everything to my path. It is not in my path. Well, that is awkward. Let me check my system settings then. Advanced system settings. Environment variables. System variables. I guess we'll just add it ourselves. Yes, export path equals that. We'll just cheat now. Dot. Oh. There's Graphviz bin. Okay, all right. We'll cheat. Something about it. Export path equals that's not what I said to do, you pile of manure. Okay. Okay. Echo path. Now Graphviz is all pointing in the right direction. Dot. What? Oh, okay, fine. I guess we'll do it that way. /c / program files. Dot -v. We have version information. Okay, dot -t png of something. Test dot dash o test dot png. Let's see other options I want. Name, information, layout, t library dash o. Yeah, let's just see what it does. Two, three, four, five, six. Okay. So let's hack up our file real quick, just so it's we can figure out what works. Just go with blue. It's not a known color. I could swear I was looking at color information. Here, color list. And they have to be named. Color. Oh, hash. Needs to be a hash. So let's put that all back the way it was, except for some reason the 0x prefix is not used. Probably due to influence from the web world. Illegal value, color attribute, float expected after semicolon. Okay, let's take that back out then. Clearly there are restrictions that I don't know about. So let's pop up the what we outputted. Let's look at what our graph looks like right now. Test.png. A little dark, but it's the application called Photos. So let's put this on the same thing with OBS, otherwise OBS has a hard time finding it. Add a new window called Photos. Nope, did not catch it. Why? I don't know. Window capture. Ugh, fine. There. This is our graph right now. This is our start state, which we will make a little bit lighter. And these ones with the double circle can accept. It means that these are valid states to end in. Here's our NFA and the pattern we generated from. So we're getting there. Let's go 4, 8, and F. Just to see what that looks like. Okay. Oh, that's a little better. Yeah, maybe a little bit too bright. That's okay. We'll bring it down. Or we can make it dark. Let's make it darker and make the text lighter. 4, 8. Text color equals hash. Maybe like for a nice light gray. That is not gray. Text color apparently is not the right answer. Oh, font color. Okay, all right. Oh, there we go. I guess that's sufficiently distinguished. Okay, and we'll go back to this way of looking at things while we find those changes. Fill color will be dark. Then we actually also need font color. For any start state, we want so all colors are now hash prefixed. So for any start state, we want something like Coco, otherwise that. Okay, we're getting there. Slowly putting it together. I'll run it again. Okay, now we share screen and look at. Okay, so we outputted this good. Back to Emacs. Okay, so we were outputting the states. Edges. So here is where we output how to draw the arrows between the edges. Let's just start with the most basic, going back through the states. If state point to out of 1 is not equal to null, then we can write. No, let's get the next state. We'll catch it around. Count 2. Okay. Then we can print f 1, 2, 3, 4. And we want state modulus 0 to d going to state modulus 0 to d state pretty sure we have this as like an index or a state ID. Okay. Should probably use that here. State, we're going to state. There. I think that's basically it. We'll just see what that does. Oh, I need to put the output. Link the output. File. Close out. All right. Now we should have the connection information. Let's look at that. There's no information. Did I not build and done it correctly? Not seeing this outputted, but it might be my log levels. I'm in debug, it should log everything, so why is this not getting reached? I'm going to pause briefly for a restroom break. Then we'll come back and make this work the rest of the way. Okay. Without seeing any output on the command line, we're going to throw this in a debugger or add a lot more log lines. Oh. Here's what we're gonna do. Okay. Source, builds, debug, maybe. Our test case was start of line A or B, C, end of line quote. Then we run this. There we go. Okay, now we can come over here. Screen. There's connection information, although that's not quite what I wanted. Two sets of things. And it's not showing the right things anyway. Oh, 0, 2D. That's why these are creating new states. All right. So they don't have the same name, so it's creating a new entry. That should help quite a bit. Okay. There we go. State 0 is not circled, so that's awkward. Um. Oh, okay. Again. Still me being a little bit on the silly side. No new line there. Okay, all right. Why did I not put a new one there? I don't know. I'm used to using my own logging class, I'm afraid, which deals with all the new line stuff for me. Okay, back to it. Boom. And I think I know what's going on here. This should point to two different things, because this is an alternation. Otherwise, we're close. Super close. I believe I have a typo here when we were pointing at the wrong thing. All right. There we go. So this is an alternation, which goes left or right to, if I'm not mistaken, this is the start, and then A, or it goes B, C, end of. So the shape is right, and the state numbers are right. I would like to make this export bigger stuff. This is, oh, we can increase our resolution. Do I remember how to do that? Where's the command line? 72. dash S 144 will be our next dash S 144. Maybe we should scale it. Make it a bigger image or higher resolution. 72. It's fine, I guess. It's good enough. Mr. Ed. Okay. I'm going to tilt my other repos now. What's that bash, by the way? Yes, bash. 3.1 December 2005. Yeah, this is a MingW Cygwin runtime, tiny on my screen. Yeah, I've got my setup for Emacs reasonably well set up. But yeah, the full screen share is no good. I was trying to share just the photos window, but Windows sucks or OBS sucks or something. Mr. Ed makes most people keep their skeletons in the closet. The skeleton had to come out of the closet because there wasn't room. Yep, my closet is full of board games and books. So yes, my poor skeleton had to come out of the closet, which was very traumatic for him, I'm sure. Also, welcome to the chat, welcome to the stream. Happy to have you along. Okay, we are close to what we need, but I would like a better, I want better strings written out to my graph, which operation name const char star text or label. Yeah, it's board games and books, I'm afraid. Here we go, switch. Character an inclusion or an exclusion. These ones actually need to break up a bit. that true? I may not. All of these are I can work with. And all of these I can work with. Only kind of. A group. No, I'm not sure we have to do anything with group. I should probably be testing that. Okay. Start copy result from temp string. Actually, let's just get rid of all this. Did something I did not intend to. There it is. Oh, wait. Result just equals that. I don't have to handle it at all. Perfect. New character array of 2. Whoa, that's incorrect somewhere. Why is it? Oh, I know why. It's a little bit on the silly side. There. Stir print. Let's see here. That's why are we using the overweight version here? Result sub 0 equals something. Start of line is this one. So sub 1 equals the end of string character. Which honestly we can just put all in one line. End of line is $. Any is not. Alternate. 0 or 1. 0 or more. Star. 1 or more. Plus. I guess we can put something in here. Just to in case we need it. All right. So then in NFA, get the label. Put that out for each state. Just going to make it look something like it's just called label. Label. So the question is, label. Yeah. I may have to add this chunk inside this as well, as I'm not sure what the behavior of that is. There we go. Run it. Okay, over to OBS to look at our handiwork. Full screen? Oh my gosh. Okay, so we don't have the state numbers anymore, but here's an alternation, which goes to start of line, and then A, and then accepts. Or alternation, which goes to B, then C, then the end of line, and it accepts. So there you go. That's almost what we want. I do wonder, state 0, 3, E, if it takes new line, would be interesting. Run it. And now it does. Ooh. Okay. There. Now we have the state numbers and the text. So we can wrap that in quotes. It'd probably be better. But now we can see our NFA as it really is, just like you read about in the textbooks. It's a little bit pixelated, which I don't like. Changing the scale on the command line I thought would fix that. Let's see, where's my... Yeah, I have the -S option, but it's not really... We could output it as SVG, but that sounds like more work to make it usable. Okay, let's put in some quotes. Backslash, 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 quote. I think that's what I could do. Okay, let me see if I can just find real quick how to make Graphviz larger resolution. -G D G D P I. Okay. And I missed that in the documentation. No, I can try. Pardon me. Okay, let's try that. And then, oh, that looks so much better. Yes. Make it big. Oh, look at that. Yes, that's so much better. So there we go. We can now look at our NFAs in a much more user-friendly way than just command line text. Not bad, actually. It's about as compact as I think I can make it. So let's run let's run another pattern through here. At least sort of. A through Z, and any digit plus. Or BC, or let's see, or anything which is not a quote. Question mark? Drop a question mark. Ooh. So it does not like when I do that. Let's not get too crazy, I guess. Or capitals and no letter, no number. Okay. And then we start it up and we'll see what that looks like. Here we go. Nope, that's down. What the? What full screen? There we go. So NFA is start of line, either start of line, A through Z and D, which is not quite what I want because the backslash is not being preserved. There's no square brackets. We can improve our formatting here, but it's fine for now. Plus, or we get capital A through Z in the end of the line. Okay. I think that's good enough for now. We can come back and upgrade that. This is much more readable than before. No, we can make it better now. Let's make it a little bit better now. Not a lot better, just a little bit. Just a little bit. It mostly has to do with this piece of code. So if it's a character, I want this. That's easy. Otherwise, oh yeah. All right, now we need that char star temp string. Our temp string is going to equal to our inclusions to string. If inclusion set sort of like a Boolean. It's not. Okay. Oh. So I don't have to ask. This is fine. This is fine. Result equals new character array. The len hamster plus one stir copy into our result following string functions s. We're going to copy from temp string. Then we'll delete temp string. And that's basically it. Plus 3. This one needs 4 characters extra. So we added 1 character for the square bracket, 1 character for the square bracket, and 1 character to hold the end of string token. This one is an exclusion, so it looks like that. It needs that extra character. That should help a bit. Oh, yeah, sprintf. Sprintf. Okay. All right, taking a look. Full screen. So A through Z, the D is not being escaped properly, but I'm semi not surprised at all. There's no backslash there. There should be a backslash there. Because I only set the text for this rule, this piece, based on the character I'm at. If I included, we make one more minor improvement. We almost have it perfect. Patter-to-NFA converter is in escape equals false. Anytime we clear this, do I have last? Or previous? I don't have a way of looking backwards. In escape. UTF-8 character reference escape char. Whenever we go in escape equals true, escape char equals our UTF-8 character. In escape equals false whenever we consume an escape character. UTF-8 char with our escape char. Oh, no. That's fine. So basically, if we didn't have to escape it, we can just dump the letter straight in without using that. Okay. Here's the other place. Yes. Yes. Yes, yes. yes, no. Yes, yes, no, yes, 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 no, yes, yes. No. 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 Oh, oh, this is the same story here. UTF-HR. There, I think that's it. Then what we can do where we go inclusion rule to string. This is, and I need to get string length. Okay. Oh man. Start C equals backslash character result plus, make the result bigger. If this is a range, we have to kind of ask the same question about the end character. That is an escaped character. Then we have to make the result bigger. So the one here is for the hyphen. For example, A through Z, right? I'm going to compute the string length. Start C string. Oh, okay. If start C string is not equal to, or is, yeah, is equal to escape character, we gotta do something else. Otherwise, we do what we've always done. Start character, there we go. Let's see. Okay. Char temp. What's new? Character array of size something. Start C dot bytes size plus one more byte for the backslash character plus 2 bytes for the end of string. Okay, then. Oh no, we get that either way. We're always getting the start C string. That's F into temp backslash after this S. Start C string. Delete our start C string. Then our start C string equals our temporary string. Except That's not quite right. It's almost right. Very close to right. We don't want the start C string because we've just said if it's a backslash, if it's an escaped character, we only pass in the backslash. Therefore, this happens. We get a UTF-8 character reference. Next equals start C. Next dot advance. Start C string. Oh, this gets complicated. So close, I think. String length needs to be reworked. If we have a backslash, we get the next character by looking at the current character, moving forward one. Then we get the next character's string. Then we make room for next character byte size, +2, one for the backslash, one for the end of string character. Then we print, then we delete our old string, which is now outdated because it has no backslash. Now we have a backslash character. And we're done. Okay, so that's the start string, which means that our string length rule is wrong. Okay, so this will need the next character's size plus 1. Otherwise, you just get the current character size. Otherwise, this is very similar, except it's not end character, it's the next character, and we need 2 for the hyphen and the backslash. 2 extra characters. Okay. So basically, the occlusion set says all your occlusion rules figure out how long you are, and then I'm going to create one buffer to write 2 that all of you can fit in. And then it asks for these strings. Maybe I should pass in an optional character array to write 2, in case it's pre-allocated space. That would probably be more efficient, but I'm also not that worried about it yet. Okay, temp equals this. So if end C equals escape character, do some things. Otherwise, do these things. So let's chart temp. Where's this Sterling coming from? Why are we using that? We should be using that. Why are we duplicating work here? Okay. string. Let me dump into our temporary string those two things. Oh, at which point? I think these are the same. That's really it. That's the only difference. We just except, oh, not quite. Okay. All right, one more piece for this puzzle. Start C equals and thing. If it is, then that. Otherwise, you do nothing. Hidden character gives us an N. Whew, okay. Let's compile and see how many typos I've made. Oh. Now when we run it, what do we get? Let's pop this up and see if our escaped characters are actually escaped now. This way. They are not. The \d is not escaped. That makes me a little bit sad. After we went to all that work. Let's move it outside here and just see if we get different behavior. Things treated inside the brackets is a little bit different than things treated outside the brackets, so let's just do that. Okay, so this one is also not escaped. Curious. Very curious. Could be that it's happening upstream of where we are. In other words, here. In escape. Let's take a look at all of these. Escape character. If we're in an escape, we say here's a character, but we're overriding you with this. The escape character happens here. Save our backslash, because we know we can look forward to the next character to find out the character class. All right. Add character. Here's our reference character. Here's what we're overwriting the value itself with. So that all makes sense. We are in an escape. Here's the new line. This is a little bit complicated. But all of these reference the escape character. Believe correctly. And we're looking for \t, which is a tab. D is digits. \s looks for space tab and non-breaking spaces. Oh, interesting. This is not going to output what I want almost no matter how I do this, is it? First of all, this is a range, so why is it not printing D out twice? Dot. This is a literal period, so state. This one should be fine. Huh. That actually puzzles me why we didn't see any change in behavior. Therefore, what did I do wrong? Did I not rebuild the thing? Okay, let's go to main. Just log it as a table. See what that outputs. Okay. Character D. This is not a character, this is an escaped character. Oh, D plus. Oh. Okay. Why don't we? Oh, that's a backslash. Do I have to double escape it because I'm inside of quotes in bash? Oh my gosh, come on, bash. What is this? Single quotes. There's the 0 through 9. Phew. Now I don't know what that means to this picture, so we should look at it. Full screen. Okay. We get either start of line, A through Z, and then \D actually shows up like this, which is fine. I'm okay with that. Then this one is a plus. Otherwise, we get A through Z and the character. Okay. So let's put that \D back inside the bracket here. Because both of those should work. They're not the same, but they should both yield a valid graph. A through Z, 0 through 9. Perfect. That works good enough for me. Okay. I think we're going to call that done. That is a complete feature right there. to export NFA to Graphviz. This is a much more natural way to look at text than a text tree or table. This functionality will need to be expanded when we combine rule NFAs into larger NFA. Dot. Done. Period. I think that's good. Okay, so let's get that committed. Okay, we need to better get ignored dot and PNG. Star.png. Updated NFA to export dot file Graphviz. Boom, done. All right. Is the dot file readable? Can you check for the backslash in that file? Yeah, we should look at that anyways, just to see what we're getting for output. Test dot. Load it. You know, it doesn't look right. Did I fat finger something? Because this rendered out correctly. Oh. Oh, wow, it actually accepts the new line. That's a real new line, so I didn't fat finger anything. So this is the new line, and then the quote, and then the or, and then the quote. Meanwhile, this one, yeah. So right now all the backslashes are as I would expect. Oh, radial. Radial doesn't make any sense. Okay, let's try one more experiment real quick. Let's double escape the new line. Keep it all in one line if we can. Let's see if it handles that correctly. What's the other thing I wanted to look at? Yeah, we're not doing radial. We're just doing build. We're not using a color gradient. Boom, it wrote it. Pop this bad boy up. Check our scene. So everything looks okay there. Then if we go back to here, test dot. Okay, so it does take that backslash n just fine. This is more readable though. Yeah, not bad, actually. Now, any NFA we want, we can dump it to a file and look at it in a much more visual way. Great. Let's add those small corrections to our git. And no edit. There, perfect. Next task. Steal something off our to-do list. All right, so we have an NFA. We need to convert it to a DFA. Let's talk about why. Let's see. Probably a good way to do this is actually look at this picture. Okay, so we have a non-deterministic finite automata, which means we start at our start state, and then we have one of two choices. And we always try the left first, and then the right. Where left and right don't necessarily mean visually left and right. I'm just using that as a placeholder, right? This is the first thing we try, is we look for a start of line character. Okay? If we can't find this, then we go back and try this one. So, if you make a regular expression and you match it against one string, the NFA is much faster because I never had to do any computations down this line at all. I hit this, bounced, and went here, right? So there are chunks of my NFA that I never had to visit. I never had to look at, didn't have to understand. They just, it's 3 back to, oh, that's because of plus. Okay? I never had to understand anything else down this whole line. So I can basically eliminate a lot of the states we want to run. What a DFA is going to do is it's going to say, let's make it deterministic, not non-deterministic. We want to always know if this character, go here, period. No questions asked. And what that's going to do is, sure, I have to walk and figure out all of these different options we have, like going forward or backwards, over and over and over again. It's a choice, right? We can either accept or we can keep going. But in a DFA, I always know to do exactly what, depending on the character I'm on. So there's no more guessing and backtracking. And that's what we want. We want to move forward only, no backtracking, no guess twice. It's, I have this character, this is where I go. So we're going to remove the non-determinism from this graph. Okay? Does that make sense? What that's going to do is, if you're running a lot of strings through an NFA, it has to keep guessing left and right. And backtracking. If you have a DFA, you can march forward and never have to guess. So if you're going to run a lot of strings through a regular expression, it's better to compile it all the way to DFA. Finite state machine. Yes. Yes, these are deterministic finite automata, or non-deterministic finite automata. Finite state machine, yes. Means that we have a limited number of states. We don't have infinite states. So I think our next mission is to move this task to our journal. And we may just start. I don't know how far we'll get today. But that's what we're working on for the rest of the day. What do I got? I've got a good 3 hours. Looks like a 7-headed monster in class. Yeah. Yeah, it can. And these are actually going to, you're going to see, this thing is going to become huge when we actually implement a tokenizer of interest. Right now, this is a toy. It's just a toy. So we're going to make this huge. There will be, I don't know, well, I mean by huge, maybe it's a few hundred states. Still enough to be hard to trace. That's why we trace against these small ones to make sure we have it correct before we get too carried away. Yep, just a way to think. Just a way to understand what the computer wants to know. Programming is teaching an absolute idiot how to do very simple things. And it usually means you have to break it down far, far simpler than you ever thought you would need to. Okay, NFA to DFA. I've done this once before in my sandbox. We will probably steal a lot of that code and clean it up and move it to our current world. This is kind of the last piece we need. Well, we need 2 pieces. Right now we're just running test NFAs. We're going to take the NFA for each rule and we're going to combine all of them into a single NFA, then generate the DFA from that. So each rule does not get its own NFA. We're going to mush them all together. So that's pretty straightforward, but we might as well, while we're doing small scale stuff, test the DFA. So we do this, then we mush all our NFAs into one and go with it. And that's where things get interesting. So let's go steal some old code. Sending curriculum, they ask for test and QA knowledge. Let's see here. Sorry for my stupid question. What is expected in a web junior idiot? Oh, a junior web dev? Probably HTML, CSS, and JavaScript. Maybe they want you to have a little exposure to React or Vue.js or some framework on top. But they, as a junior, I never expected much existing knowledge or experience. As a senior, I'd expect you have, a large handful of tools that you're familiar with, which shows me that you know how to learn more tools. I'm not a web developer. I did it for a while and I hated it. So a web developer probably needs to have a decent portfolio. Even a junior one should be able to slap together a portfolio example web page. Yeah, I'm not a web dev. I tried it. I didn't like it. I moved on. Yeah, they probably want a written test in an interview. They'll give you a puzzle or something to solve, and you'll solve it. And they don't really care, as especially in junior dev, if you can solve it. What they want to see is how you think. So if you sit there and you look at the problem they give you, and you don't know how to solve it, it's okay. They may have even given you a much more difficult problem than you could ever solve as a junior. What they want you to do is sit down and show that you know how to think. So maybe sit down and you draw a picture of what the problem is. Maybe you start writing down different ideas to try. Maybe, say, hey, what if we did a linear search algorithm to start with? And then, note to yourself off to the side, oh, we can make it faster with binary search or with a hash lookup. Or, you can just start writing down how you would tackle the problem. As far as you can get, it'll show them that you can think. That's way more important than getting the right answer most of the time. I would actually run my interviewees through a very, very simple coding problem that I expected them to solve, and in a reasonable time and in a reasonable way. Like, count the number of vowels and consonants in a sentence. That's it. And if they couldn't do that, I knew they couldn't code. Sorry for one more stupid question. And the other, what areas can I begin as a dev? Oh man, there are so many. You can do embedded systems, real-time operating systems, robotics, desktop applications, DB stuff. Yeah, DB stuff. I don't like DB stuff either. Like, I don't mind DB as a tool that I might build with, but I wouldn't want to do it professionally as a full-time job. Plus, it just sounds boring. To me, it's boring. Not my kind of puzzle. I know everybody's not the same, which is good. Otherwise, nobody would ever work on the web or database development at all. So yeah, idiot web dev, study Harbor. You got to start somewhere. You got to get paid. It's not my cup of tea, that's all. Yep, you can make money as a web dev. For sure. But yeah, hopefully interviewing questions, like I said, if it's something really simple, like find the average of a list of numbers, they would expect that to be cranked out pretty fast, pretty easily. But if they're asking you, hey, how would you design this system? They want you to show that you can think. Draw pictures, write down ideas, things you might think about. Corner cases. Doesn't matter if you solve the bigger problems like that. Just want to tune your Beetle. Well, if you're able to separate your professional life from your Beetle tuning, Yeah, you can be fine there. Me, I actually like the programming itself. Like it's a it's my thing. I like it. I enjoy it. I like getting a hard problem and solving it. And by hard problem, I don't mean this microservice won't talk to that microservice. So for me, it just became so boring. I like the challenging, interesting puzzles. How do I make this run fast enough in 30 frames per second with a 12 million poly model in the scene with rear view mirrors, so it's actually 3 cameras. Optimizations, those are the fun part for me. Yeah, have a portfolio. Portfolio will help. Just have an example web page or something. Okay. They'll ask you a lot of questions about things you won't know, and it's fine. Okay, NFA and Graphviz. Let's go look at what we did before. Compiler core, DNV. I think I called it DFA compiler here. I'm not going to call it that.
I know.
Elsewhere. Good heavens, I used a lot of the standard library. I usually don't do that very much. Like 1 or 2 per. This is a bad one. Alright, so we have to know about NFA and NFA states. Fine. We have to know about DFA, DFA states since we're generating those. That's fine. Here's our text file. This is our comparison. If our state IDs compare differently for when we sort. That's right, we do have to do a sort. Before we declare a class that we'll define in this implementation file, we're going to say, here's what is an NFA state set, and here's an NFA state vector to store them in different direct ways. Okay? Compile, again, here's our NFA that we're passing in. Here's the DFA that we're returning or writing to. I think in DB source, we changed it so that we create and hold the DFA, the NFA instance here. So I think we'll probably follow this pattern. Would it be better just to return it? Might be better just to return it. Do I want to make that change this late in the game? I do. You should get the result right away. Okay. I want to be consistent between the two converters. Okay, so here we're going to create the new NFA. We're going to go through a bunch of stuff. If we have to, we destroy the NFA if there are major errors. And then we return our NFA. I think we can keep this around in case you ever want to ask for the last NFA generated. Just in case. And then it's up to you to check and see if the NFA is null. If it's not null, set it null, delete it. Yep, okay. I think I like that pattern better. So go back to main, just make sure we didn't break anything too badly. NFA star NFA equals this mess. If NFA not equal to null. Do things. Okay. All right. Small test case. Okay. So back to our DFA compiler. So we will do this where we pass in the NFA, and then we will return a DFA. So that's a change we will make. Compute closure, find or create, collide, join, compute DFA states, optimize DFA states. You're probably not going to do that right off the bat. Pick best state. Yeah, these two will probably not be in our initial implementation. Otherwise, I don't think this is too bad. DFA state, we're basically going to copy, I think. And nothing else, I think, needs to be any different than what we've got. So we're going to copy DFA state. We're going to copy this stuff. We're going to reshuffle things around a little bit. But we'll talk through every last detail as we go. It's going to be VB source NFA to DFA converter. Paste. NFA to DFA converter. Oh, oops. I did that. NFA to DFA converter. DFA converter. So this should be very similar to the pattern to NFA converter. So the pattern NFA, NFA to DFA. Okay. Compile. We're going to change the compile static. We're not going to go static. NFA start compile. NFA start or DFA rather. No, it's not marked. This is const. Okay. Okay. Let's comment out those. That's basically it, I think. This really isn't that bad of a process. Okay, so to the DFA compiler. Compiler to NFA to DFA converter. We are removing those two. Put in a block. If we want to put them back together later, we can. This class holds a lot of intermediate information we need. Oh yeah, this was probably the messiest part of this whole program. I didn't want to copy many things, so we're storing pointers to stuff all over the place. So the question is, after we're done with this, building this transition, what can I clean up? What can I delete? And I don't think it's clear in my mind yet what that is. So that I'm not sure about. Log, sure, etc., etc. I think everything is public. Oh, this is the NFA. Yeah, everything's public in the transition class. That's just a helper class. Okay, here, if a star, we will return one. DFA star underscore DFA. So we're going to do this very similar. Did we do this all static? Oh, we did. I don't want it static. We'll change that. We don't need a reference to the DFA or the NFA. Because those will be always present here. I think that's better. This will make me happier at the end of the day. We have to multi-thread this. We don't want it to be static and have shared state accidentally bleed over. So we're just going to maintain all of our state. Underscore DFA is null. So is the NFA to start with. And there's really nothing else to do in those. Compile. Underscore NFA equals NFA. What am I doing? What am I doing? So in our pattern to NFA converter, we made a destroy NFA. I think we need a destroy DFA. Which will look very similar. Except it's just the DFA we care about. We never do anything to the NFA that I recall. Okay. Why put that there? Destroy DFA. Oh dear. Hold on a second. What are you doing our destructor here? We do not clean up the resource we created because we assume somebody else took it and is running with it. Also for consistency. So we do not destroy in our destructor. To do look for error conditions and destroy DFA needed. Not sure where else I would have done that, but maybe it happens in the middle of the run. Okay. So function, blah, blah, blah. I have changed my coding styles in the years since I started this, so start with a cleanup. Hey, look, a do while. Every once in a while, a do while is exactly the right tool, and I hate it when I can't use it in Python. Like, oh, this would be so easy if I could just do a do while, because it goes through it once and then loops. Instead of, I don't have to write all of everything outside the loop and then inside the loop, or break it out into a separate function, which makes it harder to read. Sometimes a do loop is just what you need. In fact, I have an idea for an even better looping construct, but we will have to wait quite a while before we get around to using it ourselves. Okay, so compute closure. Here's what's happening. We have a list of states of the NFA that we are at, and we're going to start this with start state. Okay? And if we just have a vector with one state in it, then what we're going to do is we're going to go through and say, for every one of these states that we have passed in, we're going to add them to our closure. What does a closure mean? We'll talk about that in just a second. Then, so we just add all of these straight into this right off the bat. Part one. Then we go through all of the things in our closure. And we're going to say, unless we've already added you, we're going to flip the switch and say, yeah, sure, we don't have to worry about you anymore. And then we're going to ask, is this state an alternation? Do I need a left and a right? If it is, oh, so alternation. Here I'm using the word alternation slightly differently. So let's look at NFA state. Alternation means you have two choices. And it's anything between alternate, the actual operator, and all the way through the end, right? It means we have a choice. So we look at NFA state, HPP. None of these are a choice. I just say, I have to match this character, I have to match one of these characters, I have to match any character that's not this character, I can match any character, I have to match the start of the line and the end of the line. There's no choice. It's match or nothing. Alternate, well, I have a left and a right, 0 or 1. Well, I can make a choice. I either don't see the next thing, either don't see the thing, or I see one of them, nothing more. So each of these are a choice, okay? So when I ask, is this state an alternation state? It turns out that these are all alternation states. Okay, so back in the old NFA to DFA converter. So that's what I mean here. If I have a choice to make, then I try to add the next state. So add out 1 and out 2. And that's basically it. So let's look at our picture. Where's my picture? Picture. Screen scene. Okay. So the closure. So I'm going to start off parsing this thing by putting start state in that list and saying, find the closure. Well, this is an alternation. So I'm going to put this one into my closure. Then I'm going to say, well, this is an alternation. So we're going to grab this one, put it in our closure, grab this one, put it in our closure. And then we're going to try it again. We're going to say, is this one already processed? It's already processed. Let's look at the next thing in our closure, which is this one. And we're going to say, are you an alternation? It is not. It's a start of line character match. So it's done. This doesn't add anything to our closure. This one also doesn't add anything to our closure because it's a match a character. There's no choices here. No left or right. Unlike state 3. If state 3 is in our set somewhere, then it has to include its two options. Its two options are to accept or to go. So hopefully that explains what closure is. So the closure of state 0 is state 0 and 1 and 4. That's the closure for this state. Does that make sense? So I want to make instead of running the NFA, I'm going to literally run the NFA and take every choice until I can't take any more choices. That's the closure. Hopefully that helps explain what this does. Slow me down, ask me questions, let me know. That's all this does. Everything incoming is added to our closure, and then we keep trying to add more stuff to our closure until we can't add any more. No more choices to be made. Okay, so that's that one. Find or create. We're not passing the DFA in anymore. Oh, well, let's just. So that's compute closure. This one, we want to say we have this closure. We have a whole bunch of states, right, that we've decided are all our closure. And I have this new thing that I want to check against. So the question is, does this already exist in our closure or not? If it's not already in our closure, we need to create it. So I have a flag for saying, did we create this or was it already found? And add it to the closure. That's all this is. Find in the closure this thing or make it. That's all. If our closure equals our key, we're done. If our find a match, if we find a match, the result is the thing that we found, right? Otherwise, we have to create it. So we set our creation to true, make our new DFA state, add it in, assert that it was actually created, add it to the list of the DFA states, push back our closure, and if the closure is empty, we can accept. That's just the way the logic works out. And then return our new DFA state. Does that make sense? Collide. I'm wondering where that pops up in the code. Okay, it happens in here. I want to completely refactor the way I do this for now. Do the simple thing here. I did something very, very complicated here because I wanted to, not because it's right. What I want to do is, once we get this working the simple way, we're going to come back and say, is the complicated way generating faster code? I think it will, but I don't know if it'll be a significant amount. So that's what I want to test later. Do the simple thing here. Once it is working completely, do it the complex way and measure the performance difference in the generated code. I have no problem having my parser generator run slower as long as the code it generates is faster. The tokenizer generator can take a couple of seconds, right? I don't care. But when I want the actual tokenizer to run, I want that screaming fast. So this is one of the things we're going to do. Okay, back to Collide. We're going to comment out Collide for now. That one will move down here. I think we will simplify it a bit though, so it generates less lines of code for us. Oh, we should do that here as well. Not too bad. Okay. Boom. Collide is a big thing. Right, let's change my coding style real quick. It's a long story, and I really do want to get to where we can talk about it. But I want to solve it the simple way first, so we have a comparison. Was it worth it to go complicated? That's what we want to ask. A lot of the times people are like, oh, I have a list of 10 items I need to sort. Why don't we use a quick sort? It's like, well, for very, very small sets of very simple types, it's actually faster to do a bubble sort. Like, bubble sort is not evil. It has its place. If I remember right, I think OpenGL used back in the day maybe a bubble sort for certain types of sorting of its state. Because it's such a small list, it was just more efficient than to do all the other sorting nonsense. Sometimes simplicity wins. Like a lot of old game coders who had to really squeeze every last ounce of juice out of their machines, a lot of them never wrote hash maps, right? They would just write an array of stuff and just blaze through the list. As long as it didn't get too long, it's actually faster than dealing with a hash map. There was a lot of debug statements in this code, I remember. Holy smokes. Sorry, just about done with the minor cleanup here. Boom, done. Okay. Ooh. So computed closure, we did find or create. This is basically finding the DFA state for these keys given this closure. All right. Next, join. I don't remember where this is used, but basically, here's a list of NFA states. Here's a list of NFA states. Put them together, and into a new NFA state set. That's all. It's basically the union operation of NFA state sets. Nothing too interesting there. Join. Joins vectors instead of sets. I don't remember. This is safe. Oh. Like this could potentially end up with duplicates. Am I okay with duplicates? I don't have a memory, so we will just do check if A, B can have overlapping states, which would result in a state being added to the new vector twice. All right, loose ends list for me. Compute DFA states. If you no longer need to pass in NFA or DFA. Oh, so many debug states. This needs a bit more than just some simple reformatting, because the NFA and the DFA no longer passed around. Where is our NFA itself proper? Is it ever referenced? Huh. Okay. we have to know if we created a new DFA state, because then we have to move on from that DFA state to the next one, if it was created. Did we create any state? We're going to loop through over and over again, looking for new states to add, until we can get through the loop without flipping this to true. Okay, so this is, if we created a state, we've invalidated all of our iterators, and we need to break out and pop out to the top and just start over. Closure keys, temporary NFA states, just a thing for us to keep track of stuff. Here's our first closure. We're actually going to pass this around a lot to get new closures from it. Here's NFA, M underscore. So again, we start with just our start state. Then we compute a closure. M underscore DFA state, underscore DFA state. Find or create M underscore DFA, underscore DFA. I don't remember exactly why I did that. I lost track of memory somewhere, so we should try to actually catch it. Preloop found null state at. I don't remember. If this is an acceptable state, like we can reasonably continue working with this. Oh, this is if we have debug turned on. This is just for logging information. Okay. More logging information. Here, I think. So basically, let's see here. If you want it screaming fast, will you translate the DFA to machine code? Oh yes, you're new here. I will show you what kinds of things it might be generated into. I will show you. Let's see. So back in my old sandbox days, like I worked on this a couple of years ago, just in my free time. So this is us making it more productized, more planned. Everything else up until now has been very exploratory. So let's see, active projects, compiler core, V and V, EV, there it is. And now we want the, and no, we want the Billy tokenizer. Okay, so when we ask it to tokenize some string, this is kind of what you're looking at. You have a little bit of a switch statement at the stop, because I do support a full push-down finite automata. Clear block state. Where's the piece of interest here? Not the accept, not the accept. Parse root. We are going to good old-fashioned go-tos and labels. That's what we're going to do. Well, okay, we're going to implement it 2 or 3 ways in the end. We're going to have a flag so when you compile, you get switch statements for the state management. We're going to write it one way so that you get an array of function pointers as your state management. And we're going to write it a third way where it's this. Labels and go-tos. No function call overheads. Just hard machine jumps. And we will measure how much each one, how much time we save using the different methods. So we're going to actually generate many times more code than we need in the end, because we want to measure. You can't know if it's fast if you don't measure. So hopefully that makes sense. 3 methods. Switch statement, array of function pointers, and lastly, go-to labels. So, like, yeah. And this comes directly out of having a DFA. Once you have a DFA, writing this jump table is trivial. This is, yeah, it's beautiful. So that's the plan. By screaming fast, I'm hoping to. I don't know what screaming fast means when it comes to tokenization, but we're gonna try. We'll see. We'll see how fast we can make it. So yeah, there you go. Hopefully that answers your question. Back to code cleanup. So here we basically preloaded everything. We got our first state out of the NFA, computed its closure, added a state to the DFA for it. Start state. And my NFA I call root state. Now that's inconsistent. I do call it root state. Okay, I'm gonna add this to my to-do list as tech debt. NFA calls it root state. DFA calls it start state. Get consistent. We won't deal with that today. Okay, so this is us preloading the system with our first closure. Then, with all these debugs in, I remember I needed almost all of them to properly understand what was going on. We set some initial state flags for iterating through this loop over and over again. Okay, we have a list of transitions. So a transition. This basically maps, here's a DFA, and here's all the NFA information we need to know about that contributed to this DFA. So here's a list of all the processed things we've already processed. And unprocessed means we found it, we know we need to do something about it, put it on this list, we'll finish grinding through it later. And as they get ground through, they get moved to this process. Okay. Then, like I said, for each closure, I have to ask a few questions. One, is it terminal? So basically, does this not have a choice? That's basically it. And, oh. So this terminal means you don't have a choice. This is not an alternation. It is not a 0 or 1. But now we have special case. Oh yeah, this is. So here's the thing. If you think about it, a character match is the same thing as a one character inclusion, like a one character inside your brackets. Doesn't matter. Any. Okay, so let's see here. Let's write this out. Let's go to our sketch buffer here real quick. And NFA state.h. Let's look at this. This is our list of terminal operations, meaning there's no choice to be made. We just do the test and then move the only direction we possibly can, or accept, right? So this is things like, letter A. These are things like A through Z and 0 through 9. And exclusion means any character which is not in here. So just flips the logic. So maybe you don't want any digits. You'll take anything that's not a number. Okay? If you think about it, all that any is this. It's the empty exclusion. Exclude nothing. That's all any means. Depending on your regex engine, it might exclude new line characters. But we're not treating it that way. We're accepting anything. If you say dot, you better mean dot. But start of line is not actually... Okay, so this A can be the same thing as an inclusion set with the A in it. Okay? So up until now, we've had these four. They're all terminals. And all of them can be thought of as a brackets with a Boolean flip. Except these two. So we have to treat them specially. Doggone it. Because these don't consume a character. They don't have to match a character. They have to match a set of conditions relative to the current character. So let me think about that. NFA state is terminal. Oh. Oh, interesting. We did not upgrade that. Start of line and end of line are also terminal. Okay. So in our DFA to NFA, oh, backwards. NFA to DFA. So in here, it's NFA state. Operation start of line or end of line op equals NFA state break. Basically, we have to preserve this. Unprocessed pushback. So we're just adding this transition into our list of unprocessed things. Okay. So already we have some minor differences. Okay. Let's put all of this remove collisions, done. That's here. Boom, done. We'll trim up this code a little bit, but this is a complicated process. I want to come back to this once we get something working and have this as a build alternative so we can measure performance. Okay, we got through there. Now we finalized the DFA state. So we've gone through a bunch of stuff, gathered things for the DFA state, and now we should have enough information to build the actual DFA state. Here. We find or create. If we created it, then we have to say, remember, we got to break out and start at the top of a loop again. The transition can accept, blah, blah, blah. Okay. And then we add to our DFA state a transition, which is, if I'm in this state, what do I have to test? Ooh. Here are the characters I have to test. Is this an exclusion or is it an inclusion? Is this hard-coded exclusion? Here. All these debug statements here. Let me see if I can hide Emacs. Hide CMAC or collapse or something. Hide if def. Let's try that. Hide if def. Well, that certainly didn't hide anything, did it? Oh, the compiler would remove. I just want to collapse them. Well, whatever. So why is this hard-coded as an exclusion? Breach transition, closure, DFA state. Was the state created? If the transition can accept blah. I honestly don't remember. Oh, this is a Boolean. Okay. Okay. So we need to actually change that transition. It needs to store, not a Boolean, it needs to store one of 4 options. Inclusion, exclusion, start of line, end of line. Those are the operations. Then we need the rule ID and the token ID so that we can properly mark our tokens as we generate them. Okay, so this is the thing we will have to change. Transition needs not bool. Okay, we'll come back to that. We're just doing a cleanup pass here. Loop count, yeah. If we've created any state, then we've invalidated our iterator and we need to pop out and start over. Okay. While we have processed some new DFA state, until we can go through the full list of DFA states and find no changes, we keep going. This is another reason why we love do while loops. I think that's it. Okay, so we need to copy DFA state from this world. This contains the transition, and this Boolean now must become an operation. An NFA state operation. Which I wish we could use meta programming to copy the NFA enumeration here. Why is this a friend of the DFA compiler? I like friends. I don't like friends. What is private here? Nothing is private. It's all public. Oh, I see. No, I don't see. Everything's public. There should be no friendship. We don't believe in friends. We don't like friends. Nobody needs friends. All right. Oh wait. This is the one I want to copy. In my other project. The source NFA state. Paste. Okay, we're not friends. We have no friends. We don't need to forward declare the compiler. Transition. Okay, so we're gonna cheat a little bit. Okay, state. We're gonna copy this. Note. Must be synchronized with NFA states. List of operations. Okay. Then we're going to pass in a DFA, well, an operation. DFA, that's here. Operation. Okay, I'm going to go over to DFA state, copy, and modify the other one. DFA state.c, copy, paste, DFA state.http source, DFA state, paste. Okay. And delete all our transitions. That's fine for now. Okay, transition. Rule is exclusion needs DFA state operation. Off. Oh gosh. Yep. That change to op is a problem. We'll get there. We've got to work through this though. It'll take a little work. If equals NFA state operation start of line. Who gives us? Oh darn it! Boom. We probably should put a warning around this one as well. NFA state on copy. State C. I don't want my DFA to reference any code from the NFA. And I think if this is the only thing that we have duplicated across the two places, there's no reason to abstract a third piece between them. Especially since technically DFA state doesn't need most of these. Like all we really need are inclusion, exclusion, start of line, end of line, etc., etc. I think this is okay. Therefore, in our log function, back to the logging, it will be either exclude or include, or equals DFA state operation end line. DFA state name of so if this is a start state, oh, so if there's a negative number and it's uninitialized, basically it's not been put into the DFA. So we would use this one for while we're building up the DFA, keeping track of states, and then once it's in the DFA, it would have properly assigned IDs. So I think that's okay. Next, index. Oh yeah, we changed that in NFA as well. So in DFA state dot h index state ID. Thank you. Index state ID. Okay. If we are start of line or end of line, we don't need to look at inclusion at all. There's nothing to do with that. So I guess we just put most of this in here, except that simplifies, and that simplifies. But I just get state. Okay, which probably means our DFA, our NFA to DFA converter. How many places do we use state index? Not that many, actually. How many more things do we break? NFA converter. We did a thing last time where we found dot search for dot o space colon grab the CPP file, search for this character, and replace that. Okay, we almost had it working. Dot, let's see here. Nope. F3. Search for dot o. F3. Search for dot o space colon. Go to the end of the line. Search backwards for the first space. Forward, backward. Search for $. Parrot. Put that in there. Center F4. There we go. Okay. Pattern to NFA converter goes to NFA to DFA converter. 2, 3, 4. NFA to DFA. 1, 2, 3, 4. 1, 2, 3, 4. Okay, last piece we need to steal is the DFA. Run a compile. We're still looking good on time. We're gonna break tons of stuff. There's no way this is all gonna come out correctly on the first refactor of old code from sandbox from 2-3 years ago. No way. How bad is that refactor? It's actually not that bad. We could do that today, probably. Let's put it in our journal. Okay. Okay, so copy the DFA state. Let us copy the DFA, which is very simple. We really just expose all that. Yeah, here we actually hide them away. They're not public. We only have access to root. Which probably means we should do the same thing for DFA, question mark. Not sure how I feel about this. Voodoo. Tech debt. DFA exposes all states publicly. NFA does not. Make that consistent. That is a bigger refactor than just renaming root to start. Start state, set start, start, set start. This is going to blow up all kinds of things. Does NFA not return start state? That is little. I thought we had that.
Yes.
Right? This is going to blow up all kinds of things in NF Pattern-to-NFA converter. Root to start. Set root state. Okay, back to DFA. It's a very simple thing. State is null. Let's be consistent about our initialization. Clear. Every state in states, delete it, and then clear it. Log. Yeah. DFA is fairly straightforward. Okay. Let's see how bad it was. Oops. File. All right. Yep. Should not exist in here. Do a clean debug. Let's rebuild all kinds of things. Okay. Result is true.
Maybe. You have a baby? No. And where's the baby?
Oh yeah. Why do we need a text? Oh. Here's where I thought all the errors would be. To state ID. Invalid use of
Order
things.
downstairs. What?
Found a
Order
match.
downstairs.
States at
Uh-huh. Welcome.
oh. M underscore DFA point two. Not those ones. Not that one. Not that one. Oh, I missed some. DFA point two underscore DFA. Sure. File. NFA does not have root state. Find or create. We do not need to pass that around anymore. Find or create. Transition T we're called to DFA state inclusion set, which in our case could be null question mark. Probably is. I would hope so. Operation int candidate DFA state inclusion set pointer operation int state inclusion set operation int. What? DFA state operation. I'm just gonna cast it. I think that's what it's complaining about. Oh wow, that actually worked. Yeah, let's go into our main function and see what happens. Can include DFA include DFA and NFA to DFA converter. NFA to DFA converter, NFA to DFA, DFA equals NFA to DFA of file, yes. Given my NFA address, if DFA point to thing is all I have to do there. If I could type right, that would help. Life gets hard when you can't type right. Oh, it's already an address. I've already seen it as a pointer. That's right. Okay. Let us run this. I would like that noted somewhere in the journal. Okay, let's start with a very simple string so we can understand it. ABC. When it comes out as a DFA. Well, that is not particularly helpful, is it? Good progress, though. It didn't crash. If we go to this, oh, we at least know we're getting through the NFA portion of the processing. Okay, so there's the NFA of ABC. And here's the DFA, which is essentially empty. All right, time, I think, for a short restroom break. I'll grab a snack while I'm at it. So sit tight and we'll figure out what's going on. So, the question is, why is our NFA, which is generating correctly, not generating a correct DFA? So I think that means, oops, we have to run DFA debug define. Oh, goodness. -d DFA debug. Clean and run it all. I really don't remember what the output of this will be. So we generate our NFA for ABC. We get a fairly standard set of states that make sense. Our initial state, it's done. Crank through our main loop. We have one state before we start because of this initial setup. Loop 0, we have one state. Now, process that state, get transitions, finalize the DFA state, and we're done. Process DFA state done, main loop done. Okay. Then we re-enter, we finish the bottom of the main loop, and we start over at the top. Now, before loop 2 starts, we still only have one state. One state, and therefore nothing to be done. Okay. Interesting. So it did not add a new state. Finished processing the first state. Otherwise, there would be two states. Does this have anything to do with what we chopped out? Okay, to DFA converter to do okay, as part of this process. Oh, processed. It's okay. Unprocessed. So we need to stub out some of this processing here. We're not going to test for collisions right now. There we go. That should work. Boom, DFAs. DFA 0 is our start state. We need to include the letter A. Then we go to jump 1, state 1. We need to have an inclusion. We need to include the red letter B. Jump to 2. to inclusion letter C, and we can accept with rule ID token ID 0, which jumps to 3, which must accept because there's nothing to do here. Done. So let's do a little testing just to make sure we can do things like start of line, end of line, \s or A through Z plus. Let's see what that does. Yeah, we need to clean up that logging again. Okay, yeah, let's go clean up the logging. We just weren't grinding through the processed unprocessed list. There are things we have to do. There we go. Now we have an. So our start state, we have start of line. Then we go to 1. Or we check A through Z. So it's start of line or A through Z. So let's follow the A through Z line. That's probably simpler to follow. So we go to state 2. It has to include A through Z, go back to 2 until we hit the end of line. Then we go to state 4, which accepts. Following the other path, if we go down this, go start of line, go to D1. We need the letter S. This is not S, this is white space. It's just how I printed it. Which makes me a little sad, but we'll figure it out. Go to 3. So we go to 3, we need A, 5, B, 6, C, go to 4, and we're done with rule ID and token ID 0. Because that's what we passed in. We've hard coded it for testing purposes, but this state will be very, very important later on. Cool, okay. So, question 1, do we want the DFA to contain the pattern? I kind of don't. Do we want a tabular view of this instead of this linear printout? And perhaps more importantly, do we want a Graphviz output of this? I think the Graphviz stuff looks pretty good. The Graphviz stuff is nice to follow. But we're done with that. Let's see here. Let's go to our to-do. Did we say Graphviz DFA? That's a thing we can do. That's a thing we can do. So we have a couple of easy tasks we can drop in. That did not work. Okay, so we did that, we did that. We are not calling NFA thing root anymore, it's called start. Refactored NFA to name root state to start state. Easy. Copy, pasted.
You in there?
DFA,
Okay.
DFA state,
I have availability.
and DFA
It's on my desk, okay?
to DFA converter was DFA compiler into this project and clean them up. Collision detection resolution not being handled by NFA to DFA converter. Okay. Add everything. Hit commit and now create DFAs. Done. Okay. So if I look at our to-do list, Graphviz DFA sounds useful as that is I just learned Graphviz today for the NFA to Graphviz plot. And that was very in my head right now. So if I use it again, that should help reinforce what I've already done. Table output for DFA. Anything else? I mean, what we have already is very nearly. So what we're outputting is very nearly tabular anyways. So we should be able to convert that without too much fuss. The tree output view of DFA might require me to put in the has been visited flag, which I'm not too opposed to. Maybe a little tech debt. Where are we at? 5 o'clock. I started almost an hour late. So we can go to 6 with no trouble. I don't know. Any votes? Anything somebody want to see? We can work on cleaning up some tech debt where the way we treated DFA and NFA is not similar. We could spend a small amount of time doing a Graphviz for the DFA. I don't think that will take long. It's fresh in my mind. I think this would take me a little while, but not too bad. This one would take me a little while, not too bad. Maybe we Graphviz our DFA. Yeah, I say we Graphviz while it's still fresh in my mind. All right, put this in the journal so we can get working on it. Boom. All right, Graphviz DFA. Let's go to NFA. We're just going to copy. Export Graphviz there. Let's close that one. That one. Now it asks for DFA.h. I just get it. Basically just this. And it happens right after the log function. Open up the file, diagraph, DFA, and we do not have a pattern. So that goes away. Because ultimately what's going to happen, oh, is that true? If we do just copy the pattern, we just copy the pattern, it's trivial. That's trivial, let's just do it. Yes. All right, I talked myself into it. Star. Pattern gets deleted. And pattern set to null. Go. Easy peasy. Now the NFA to DFA converter. New DFA. Image for DFA pattern equals image for NFA dot point to pattern, which I believe creates a new instance and doesn't need any cleanup. So DFA just takes control of this string's return. Done. Now we can be consistent. Label DFA colon space. What did I do for the NFA? Oh wow, I did not. Okay. 1, 2, 3 quote. 2, 3 quote. 3 quote. 1, 2, 3 quote. Modulus S. Our pattern. Our states. DFA state. This thing, we need the label, which we'll roughly copy out of NFA state. State thing, label thing. Oh no. No, this actually is very different. The state does not have a label. It's the transitions that have a label. Transitions have the label. So this goes away. State ID not have a label. Shape is start for style, fill color, font color. We do not need to delete the label. Like I said, this happens in transitions, not in our state. Okay. Then we go through the edges. And we are going to not do that right now. Yes. We'll therefore just comment all of that out. And we can put this in as a placeholder, compile, make sure it builds, M states. Agree. can accept. So what do I have in DFA state for that? Oh, it's just Boolean. Even easier. Okay. I guess I have to put that in the main. So let's see here. Let me just type the thing real quick. Let's put in StartOfLine bracket A through C /D bracket. Put all this in quotes. Plus or A through Z bracket EndOfLine. Okay. Did not kill it. That's good. Main. DFA point to, oh, let's see here. That's NFA dot. DFA export. That's DFA dot. Okay. Into shell. I'm going to run a thing. Then we want to test NFA dot, test NFA ping. And then test DFA, test DFA. Okay. Can't open test NFA dot. No such file or directory. Interesting. Did I not recompile? Okay. So it wrote the NFA dot, then I generated my DFA, then it wrote out that one. And then those things ran, so we should be able to look at cool things now. Over here, test NFA looks like this. Alternation, start of line A through Z, D. This is making me sad again. Did I did not put enough. Ah, okay. Hold on. We need more backslashes. Or can we just put them in single quotes? Okay. Nope. I need to double escape it. There it is. Okay, we got it. Okay. So this looks like the NFA we would expect for this pattern. So what does test DFA.ping look like? We have states with no connections. Perfect. Here's our pattern. That's the same pattern, so that's good. So how does this, not that one. How does this one map to our tabular output? D0 D0 is start. D1 is the start of line. The inclusion 2, 3 accepts, and 4 accepts. Okay. So we just need to get the connection information between these. So let's do that. And back here. Okay. Connection information. DFA each state. We get the state. Which contains a vector of transitions. Oops. Okay. Basically, we want this, except we need to pass in some parameters. So state ID is fine. Transition contains an operation, an optional function set, but next. So transition next not equal to null. Okay, that should give me some of our information. Oop, not next. State ID. This line is going to get very long. We're going to put a few different features in here. This label, something we're going to have to deal with. For now, let's just draw the connection information. Yes, I know. M states. Null was not declared. That is true. Transitions was not declared. Also true. I agree. My compiler is right. Okay. We're going to build, run everything. Nothing blew up. Now we share the screen. Test DFA PNG. Hey, that structure looks about right. Test NFA. Yeah, it has the same output stupidity. Okay, that's okay. Okay. Now we just need to add labels to these transitions so we know what we have to get to pass through that step. And I would like to fix that pattern issue, except pattern is kind of, well, I don't know. Let's add it to do. fix pattern output. Maybe rebuild conclusion. Because that \d is not it's the pattern I pass in, but it's not escaped enough times. Maybe adding extra escaping to the pattern. I don't know. Okay, back here. We're almost there. Let's see here. DFA. That's okay. So we need a transition label. Let's look at NFA state dot this thing basically. I'm gonna put this in NFA state in the transition here. Transition has a log function. I guess is fine. Here we want DFA state transition label. Okay, this we should never see here, which is DFA state top name of our operation, inclusion, exclusion, start, end. That's fine. Any should not exist here. Treat that separately. Alternate is the only one that should remain. These three, I don't remember what happens with group at this point, but we can basically never see these. What we get is conditioned to inclusion, exclusion, start of line, end of line, alternate. I'm betting group doesn't need to show up anywhere either. Question mark? If it does, we'll come back and revisit. Oops. Transition dot label. That is something I will need to fix if we do get here. From what I remember of the process, I don't think we should get any of those. Actually, I don't even think we should get an alternate. These are all of the options have been taken. And character has been turned to an inclusion. That's it. We should only have 4 things. Are we ready? Let's go back to DFA. Oh, I think add this to our class definition. State transition. Get a transition label. I don't think we need the. Oh, I see. We do kind of need this in here with some minor changes. We do not need the state or the new line. I do like having the quotes around our string. So we have state ID, next state ID, and the label. Then we delete the label, and we are done. Okay, let's see how that looks. Oops. Semicolons, super important. Okay. Boom. All right. Moment of truth. Hey, that looks like a DFA. State 0. If we get a caret, we go to state 1. If we get A through C, that's supposed to be a D. There's something wrong with the way we're printing stuff. 0 through 9 are not showing up here. I may need to revisit some of that. We come to state 3 where we can get more and more of those characters because it's a plus. Or we can get A through Z, go to state 2, end of line, state 4. Both of these are accepting states. That looks correct. I think my DFA is correct. Just some of this goofiness around the occlusion set outputs. But otherwise, that looks pretty good. So what we did is we've transformed this NFA, where you have to try both paths, to one where we've already tried every path and said, if you get this character, here's where you go. So we kind of turned each state from, here's a test, and you have to try the next state. We've got a state, and you do a try to go to the next state, but you don't have to try both. If this succeeds, we never have to go down this path. So it's going to be a little more efficient to process than an NFA. Phew. Okay. Questions, comments, concerns? Other than the output of this stuff, I think we're done with Graphviz. Cool. Phew. All right. We've done it. We've got Graphviz outputting nice things for our DFAs and our NFAs. Splits. I would like to know. Okay, all right. Let's see. Why is this? Okay. Let's write ourselves a note in our to-do. Under tech debt. Occlusion outputs are not good, not consistent, especially escaped char classes. Okay. All right. This is probably related to this. Okay. Awesome possum. So let's go to our journal. Let's add our notes. DFA now outputs an almost reasonable graph is it can output. We don't have to call that. I still have complaints about my inclusion pattern string handling not being escaped properly, but it is identifiable. What is going on? Okay. They can now output Graphviz. Boom, done. Woohoo! Okay. I think we actually got further than I thought we would today. All right, next project is, do we, we can put a tree-like output for DFA. We can output a tabular output for DFA. Those are both, that brings it to parity with NFA. But I honestly don't think there's anything better than the Graphviz output for visualization of what's going on. Except that it involves a whole separate step of opening an image file and generating the image file from the graphviz.file. So maybe this is valuable effort spent now? Question mark. Got a half hour, maybe an hour left. All right, let's do it. Let's bring NFA and DFA into accordance. Log tree, log table, export Graphviz. We already have visited in here. Good. interesting if I do. Okay. This doesn't really lend itself to a tree output at all. This is not just a left-right thing. I will scrap it. I'm not inflexible. You know what? This is fine. I don't need to do this. You can log it, get DFA, all the transitions, or add Graphviz. That's good enough. I don't think it adds any value, and it makes me do a disproportionate amount of work to try and fit hierarchical data into a tree structure that isn't meant for, or into a tabular version that it doesn't really fit into. So let's just get rid of those. We want to do those. Okay. DFA, NFA. Set pattern makes sense. Set start state. There's some bookkeeping needs to be done, so I'm fine with those. Returning the start state. Why don't we just do this? Make those public. Start state goes away. I want the buffer. How do I get the buffer? And clear. I'm not sure I ever do. We'll find out real quick if we do. This goes away. Patter-to-NFA converter dot. Okay, I do need access to the buffer, so we go to NFA. And all we do is we make it public. There's no reason to hide it. We trust everyone around here. This is a habit I got into a while ago to try to hide everything I could. It turns out sometimes it's just easier to just expose things. And this is not like a large project where I'm worried about people doing the wrong thing. I'm the only one on it, so just make my life easier. NFA to NFA converter. No. Got it. Let's see how that looks. entirely correct. I did not rename those in their declarations. Okay, no action function. Okay. Very near there. Okay. Just verify to break anything here. NFA, DFA, they still look the same. Maybe I should both and regenerate it real quick just to make sure I'm getting fresh files. Okay, then we'll show. Here's the test DFA ping. That still looks good. And this one. So just because we exposed a bunch of stuff, everything still works. Not a problem. So this is the NFA. Again, here's the DFA. It looks similar, but they're very different in how they are processed. Okay, so that little refactor I think is good. So now NFA DFA I don't think DFA state I don't think it ever uses visited. Is it? It is not. It was a dead member. Yeah, no difference. Didn't change anything. Good refactor. Good, good. So NFA dot H. NFA H. This gives me a way to copy out the pattern. It's a convenience method. DFA clear. Am I using NFA clear anywhere? NFA.cpp probably is in the destructor. Oh, that's it. Because we don't actually need a separate function for that. We can get rid of it. Simplify. Okay. Good simplifications. Set pattern. Get the pattern. Log things. We'll just have the states and such. Okay. All right. Now. Is DFA clear using? Nope. Simplify, simplify, simplify. Boom. I'll make sure it's still working. Run it one more time. No issues. Okay. Journal to little cleanup, really. Always nice. There we go. Clean up. NFA, DFA, interfaces to be similar. Most everything is just public. Is there anything else here? We did the NFA to DFA converter, and it exposes compile, which returns a DFA, and afterwards you can always request the DFA again. We cache it and store it, but we will not clean it up in our destructor or otherwise. When we compile, we expect you to take control of the DFA. I'm curious. Oh, am I not curious? Maybe I'm not curious. DFA converter. We could make it const. I think we can. Just a promise for not changing anything. Oh, I do need the visited state. Yeah, it's complaining about it. Okay, easy enough. Run it again, everything's fine. Re-verify that I didn't break anything. That still looks correct to me. So, I think we're good. I think those refactors were good. So, yeah, we were looking at NFA, DFA converter, and Patter-to-NFA converter. See if there are any significant differences between the two. Empty constructor. We can return the last NFA processed, and we automatically return that NFA file. Same thing here. Yeah, the interface is very, very similar. Okay, I'm happy with all that. Clean up and alignment between NFA, DFA processing. Okay, journal. What do we want to work on next? I don't want to fight the printing the outputs, making everything beautiful right now. Same with this. These are low priorities to me, like this one. I think we're to the point where we can actually start using our NFA and DFA stuff in more useful manner. So let's do that. This actually shouldn't be too bad. I think there's some stuff we did before where we commented things out that we'll have to add in. Okay. So we just go to main. All of this goes away. Not just this. We go like this. Okay, now we're back to this line of. So before we were just passing arg1 is a regular expression pattern. We're compiling it to an NFA, doing things with it, compiling that to a DFA, doing things with it. Just so we could rapidly test our regular expression stuff. But now we got to go back through our project. So let's take a look at that. Let's compile this. And now when we run, it wants a project file, and we want test.vb project. So our project says, here's the name of the project. We want to work with ASCII only. Here's where to find the tokenizer. This is what the tokenizer looks like. So we're getting our patterns now from here instead of off the command line. That's what we need to do next. And we're going to compile each of these, and that'll be wonderful. And then we will combine them. And how we combine them is actually very simple. So, project parse. Let's see. I need to change up my gun here. It's the tokenizer definition. Definition. There we go. It's in Git. We can just leave it. Boom. Okay. Parse. Remember, this parse function is really, really bad. Manually, it's garbage. We will be replacing this with some of the code we generate later. So don't get too caught up in this part. Rules and place back. Okay, so we get a bunch of rules. And each rule will create its own NFA temporarily. It does not need these ones. Tokenizer definition will. Okay. And then we want an NFA tokenizer def rule okay. Set. And copy other dot underscore NFA, but by default we don't want to copy it. Okay. If. So this tokenizer rule copies a lot of stuff. I do not want to write an NFA copy. So it's going to hold a reference to the NFA. NFA is not equal to null. M underscore NFA equals NFA. Otherwise, we do this. M underscore NFA equals pattern to NFA pattern to NFA given M underscore regex compile. Oh, do we need to rename compile to convert? Whatever. Oh wait. This is the important piece here. Um. Index. I don't like the word index here. What with rule ID? Okay, to give it when I compile. Oh, not that one. When I compile, I pass in the rule ID and the token ID. Okay. Here's the rule ID. The token ID we need to figure it out. token ID. Need that information. Boy. You know what? Keep changing my mind on a few things here. We're not passing that in. We'll always recompile it, which sucks, but I would like to know how often we really do that. How often do I do this or this? I don't think I do it that often. Let us log that. Copy constructor. Copy constructor all. And assignment called. I don't think I actually ever use these. If I ever see those, I will know. Okay. Token ID. Therefore, we never check for this. Therefore, we just always do this. Underscore token ID. Okay. Is that what I need? Anything else? Yeah, I thought about doing that. Semicolons would be nice. We never pass in an NFA, we always construct a new one, which is a typo. Thank you for catching that. Okay. EV tokenizer definition is the reason we're in this pickle. Place of back full size name. Here is the thing. Token ID. name. Who's holding the name? This thing, the name. I think we need to copy. Index less than underscore tokens dot size plus index. Token ID equals -1. If stir comp of name and underscore tokens at index equals 0, then token ID equals index, and we break. We didn't find it. Yeah. Token ID equals less than 0. Then star temp equals new character array of string of name +1 stir copy into temp name and underscore tokens dot push back. Okay. And token ID equals underscore tokens dot size. There. Now we're always computing our token ID. If we find it. If we can't, we insert it. Or we now need to clean up our tokens at the end. All right. For index 0, less than underscore tokens dot size plus index. Delete m underscore tokens at index underscore tokens dot clear, and that should do it. Okay, so we're compiling an NFA for each pattern, each rule. We're keeping track of the token ID. And can we kind of want to print the NFA table for each rule. Here's my log. Here. Tokenizer rules. Get a rule. And then now I think the VB tokenizer rule hides it away. Let's see here. NFA star NFA. Now we just take rule 1.2 NFA dot log table. Put blank line in. Then NFA. Just to make sure we're getting them all correctly. We build all that. Probably some errors. Oh, like using a standard integer. In multiple places. M token was not declared. Tokens. Eval conversion of a VB tokenizer rule to VB tokenizer rule. Oh, it's a const. Is it? I am okay with this being constant this time. I am not okay with this time. Because the NFA has been declared not const, although okay, let's do this. And detect that the other side is const, and therefore not a problem. Nope, it does indeed hate that. Get a one-liner. Why is this a const? I never said that should be a const, did I? That is not const. Okay, what about dot act? It's not a constant VB tokenizer rule. Ugh, okay. Somewhere in std vector, it is making assumptions about constantness that I do not like. Access element, access element. I want the non-const version. Wow, they're really auto rule. Rules. Rule.NFA log table. What? Why is a bracket reference automatically cost. Either. Okay. And it don't. It's stacked up very nice. We'll clean, I think. Just to make sure. It is still doing it, therefore. Run. Yes, blah, blah, blah. Backtrace. There is no stack. Let me think. These stack traces in Segment or MingW are no good. They really don't tell you anything useful. I've added all kinds of weird flags in the past trying to get them to show something useful, but it's just an awful lot of hex numbers and nothing you can actually look up very easily without peeling apart the cough file. Or the ELF file, I'm not sure which one MingW uses when it's on Windows. Okay, alright. So it's probably comment that out. Tokenizer rule. We do this. Does it magically work? We got a new code, so we can isolate which function it's happening in. Nope, it's still blowing up. Curious. Very curious. Is it in the measure definition? Is it where we are looking up the token ID? The name. Honestly, this rule doesn't need a name, it just needs the token ID. You can always look up the name elsewhere. Okay. What if we just always pass 0? Does that fix it? Nope, that did not fix it. Here. As much stuff as we've removed, I'm actually a little surprised. Huh. Hum. I think about this. Semi-puzzled. Basically removed. cleaning up our tokens after ourselves. That is going to cause major memory leaks, but nope, it's still crashing. Tokens is used anywhere now. That's used anymore. We do have the NFA here. Tokenizer rule. NFA is automatically called by set. Oh. Hmm. Okay, option one. Let's move all of this out of here. All right. Talk myself into it. Move it up level 2 BB Tokenizer definition. These will be true. These will not need to stick around anyways. We're gonna do terrible things to them that modern object-oriented people would not want you to do. It's not the way we're doing it because I don't care. Get a hold of that. If we do a full cleaning. It is still dying. Why would it die? Let's set a breakpoint. 526. Run. No such file or directory. No. Interesting. Okay, well. Print proj file name. That's PVP. Okay. Next. We have a text buffer. We will read 29, we create the project. And this is where it will blow up. Interesting, we're on line 30. Oh, on line 30. This is when we're going to blow up. PV project. Parse. Did I change anything in here? I don't remember changing anything in here. If we read the file, then we read in our token definition file. So I guess it's line 86. What did we? What is going on there? All right, let's just try line 70 in the PV project. Clear an old breakpoint. Let's see here. PV break. Delete breaks. Clear. Clear file name. Okay. Now we run. Parsing this text, line 70. We're here. String copy. Right. Name. Text. Read. Okay, then we go 1, 2, 3. Next, print. Underscore. Definition filing. Agree. Or we should go next to 81. Next, we'll print this one. Correct. So this gives us our text buffer. We told it to read a file. Definition.parse is where it loads up. Okay. Tokenizer definition dot parse. Something somewhere is busted. We're gonna find it. I'm here a bit late today, but better late than never. Yeah, well, I got a late start today, so welcome aboard. Although now it's 6:30. I didn't start that much late, so probably gonna wrap it up soon. I broke something, and it's dumping a stack trace, which in MeanW is useless almost. At least I haven't found a way to get useful information out of it. It's just a bunch of hex codes. Did I put something unlikable there? No. Um, yes, today is a compiler's day, so we're building a tokenizer generator, meaning, well, let's see. It's not hard to write your own tokenizer. In fact, you probably should. A tokenizer just takes a string of text and breaks it up into usable chunks, little bits of words, punctuation. And it's really not hard. But I'm writing a tokenizer generator because I like to. I like it. It's the kind of puzzle that I find interesting. And I like writing programs that write programs for me. So this is for my fun. It's not necessary. You shouldn't do this in your own projects, probably. As you can see, it's its own special kind of nightmare, but at least I get to enjoy this kind. Alright, so we're going to clear this one. Just clear everything. Okay, then I'm going to break point somewhere in here that is meaningful. Probably line 51, break. BD tokenizer definition dot 51. $66. What? I don't know what that meant. Let's just run it and see what happens. $78. Why? Why is it? What is this? But it can't be reasonable. We'll start all over again. The breakpoint here. The breakpoint here. Here. I didn't ask for that. Okay, okay. But it's in here. It's not going to be line 66, right? $78. Right. Did I change a number somewhere? Let's recompile it in case I change the line number. I don't understand where GDB is pointing me to. Maybe it's my fault. Maybe. $66. Run. It's breaking at line 78. So I hit this line here, right? This is 66. But it's breaking here. Why is it breaking here? What is happening in line 78? This makes no sense. I have no breakpoint near this. Oh my gosh. All right, we'll do this the old-fashioned way. Gosh, oh, you buggers. Okay. And input. We probably should. Tokenizer definition not parse. Adding modulus s name. At modulus d, which is m_rules. Size. Did not parse token. We'll do this with debugs. Good old print line statements. Adding line at 0, adding white space at 1, and then it fails. I cannot spell the word log apparently. Always fun. It never added white space at 1. Okay. Let's just print all of it. Name, actions, regex. Name, actions, regex. That all looks legit to me. Therefore, QB tokenizer rule. It is happening in here. Maybe we can get a useful breakpoint here. Breakpoint. The tokenizer rule at line 55. Run. Okay, continue. It's this one that's breaking. And what we care about are _rule ID _token ID. Okay. Next. what? Oh, interesting. Let's rerun that. Continue. Oh, the bots have made it in today. Something here? Is here my problem? Fine with that. Oh. Oh my, okay. I think I know what's going on. Let us initialize all of our members. I'll bet it's getting a non-null value somewhere. And then trying to delete it. I'll bet that fixes it. Until now, we've been lucky. There it is. Okay, maybe Tokenizer definition. If we can put all this back in, this is not the issue. Now it's pulling up. For who knows what reason. Oh, for flip's sake, Sigrid, come on. Useful output. That's all I'm asking. This is a little bit on the annoying side. Better. Adding rule. S, modulus, S, modulus, S, and modulus D, name, actions, objects, rules, dot size, Now what? It's not even getting this far? There it is. If I add this line, does that break it? Yes, it does. I'm declaring an empty vector. Fine. Fine. I can cheat. Char star tokens 256. Boom. Int m_token count. m_token is 0. But there's no more vector. It's still crashing. I don't even do anything with it. Why would adding a field cause us to crash, and then we remove the field, nothing references it? Nothing references that field. That member is never accessed. Otherwise, the compiler would be very upset at me commenting it out. And it works. Copy constructor is being called. Don't like that. Why does adding a member that I don't even use, why does that cause problems? Tokens commented out. It's never once accessed. Full clean. And it dies. Loaded modules, so much crap. Function, see this? This is useless information. This doesn't tell me anything useful. I don't know. I'm confused. This should not be what we're getting stuck on. But this seems to be exactly what the problem is. Because I'm not allowed to have that. Why can't I have a second vector? Does it want me to have std string? Is that what they want? If so, I don't like that. But nope. That is not the problem. I'm just not allowed to have nice things, I guess. As long as that's commented out, everything works. Oh my goodness. I don't know. I think we're gonna have to call it though. I'm running out of time. I gotta get going. Gotta eat dinner. So I guess we'll leave it here broken and we'll just fix it next week. Thanks for dropping in. Always nice to have you people in my chat. And yeah, have a wonderful weekend. Talk to you later. Bye-bye.